Hi, welcome to Sorcerer Classes. This is Dr. Sarkar over here, and we are solving the UPSC GeoChemist Prelims 2022 paper. Paper is paper 2, chemistry. Question is the number of radial nodes, planar angular nodes, non-planar angular nodes in 3D z square, 3s, 3px orbitals are. So for this question, just calculate the radial nodes and angular nodes, and you can get the answer. Okay. So over here orbitals, say it is 3dz square, so it will be n value 3 for dl value is 2 minus 1, so that means it is going to be 0, and l value we have 2. 3s for s, l value is 0, over here minus 1, that means 2. For 3p, l value for p is 1 minus 1, so it is 1. So this is the numbers we have to find out. So let's check. We have radial nodes, what? 0, 2 and 1. Okay, fine. Angular nodes, for the first 3D z square, it is over here given 0, but actually it should be 2. So option A is incorrect. For B, let's check. 0, then we have 2, then we have 1. For angular nodes, 2, then we have 0, and then we have 1. Okay, this looks to be the correct option. Next option you can see radial nodes for 3D z square, it's given 2, so it is incorrect. Again, for the next one we can see it is given 0. Over here it should be 2, but it is given 0, so also incorrect option. So answer should be B. Next, angular wave function for hydrogen atom depends on the quantum numbers. Over here answer would be L and ml. Total number of nodal planes possible for all atomic orbitals with the value of principal quantum n equal to 3 is what? So over here we have to keep in mind that for n equal to 3, the orbitals possible are 3s, 3p, 3d. Okay. S orbital, nodal planes are 0. For each p orbital, that is px, py and pz, there will be one nodal plane for each, so there are 3. For 3d, we know that 3d z square, we say no nodal planes. Okay, because this is how it looks. Minus, minus, and then you have a donut in between, which is plus. So as you can see, there can be no nodal planes for this type of a orbital. Okay, this is z, y, and this is x. But the rest, that is 3d x square minus y square, or 3d xy, 3d xz, yz, it will have 2 nodal planes each. That means total 8. So if we count this and add this, we get the answer 11. So over here option C is correct. Covalent radius of the C is given to be. So when we say covalent radius, obviously there will be some overlap. So this is the hydrogen, this is the carbon, this is the nuclear for each atom. So this is the internuclear distance that we have been asked here to find. Now over here it is saying what is the internuclear distance between C and H atoms in CH4. It is given for C, covalent radius 0.77 angstrom. This is given to be 0.37 angstrom. Just need to add these two. So the answer will come out to be 1.14 angstrom. That means this is our answer. For the next question, we have been given The bond distance in Cl2 molecule is 1.98 angstrom. What will be the covalent radius? So again, this is what they are looking for. Atom of two similar size, there is overlap. So this is the, suppose, internuclear distance. So this is the, obviously, bond distance, and that is given to be 1.98. So the covalent radius will be what? Just the half of it. That means we are talking about this distance. Okay, this is the distance we are talking about. So the answer here should be 0.99. Again, which of the following represents the correct order of size among O2 minus, F minus, Na plus, Mg2 plus isoelectronic species? So for isoelectronic species, we should know higher, okay, charge of anion, larger is radius or size, okay, higher charge of cation, lower is the size. So that way, if we say, we can see highest negative charge is on O2 minus, which will be having largest size. Okay, so we say O2 minus is having the largest size. Then we will have F minus followed by Na plus, and then we have Mg2 plus. So the correct option over here obviously should be answer B. Again, a memory-based question. Graphite is used as a dry lubricant in a machine running at high temperature where oil cannot be used as a lubricant because graphite has a layered structure and has layers held by van der Waals forces, which are weak forces, and cleaves easily between layers, which is true that graphite layers slip over each other. Graphite is a crystalline substance. This cannot be a reason. Graphite conducts electricity and is thermodynamically stable. This is also not the correct reason. Electricity has got nothing to do with it. Each carbon atom is a hexagonal ring, undergoes sp2 hybridization. So these are not the correct reasons. The correct option over here should be, for a lubricant you need things to slip over each other. So over here option A is the correct option.